Hello, everyone. Today we're going to talk about DBC files and how to make one or edit one using Kvaser's Database Editor. A DBC file is basically an ASCII-based file for identifying and labeling information inside of a canned message. It was developed by Vector Informatik, I believe in the 90s. And to download Kvaser Database Editor, you'll just go to kvaser.com/download and scroll down to Database Editor 3. Follow all the instructions. It will install on Windows. It is a Windows-only application. You can try using Wine if you're a Linux user. It does work, but it has some caveats to it. Well, let's get into it. So when you open Kvaser's Database Editor, this will be your default screen. You can click New, but it doesn't matter. So what we're going to do today is I've got some ISI tire temp sensors here that I'm going to need to create a DBC file to import them into a dash logger. So we're going to go through this together and write the can DBC file, and I'll just walk you through it. So the can specifications that I have here, it says it's a 11-bit identifier, so it's a standard ID. It's 1 megabit, which typically is not involved in the DBC file. It is big Indian Motorola format. It's got a factor of 0.1 degrees Celsius per bit, an offset of negative 100 degrees Celsius, and it is unsigned. We have left front sensors at 1200 decimal, a right front sensor at 1204, left rear sensor at 1208, and right rear sensor at 1212. I will say it may get a little easier if you understand hex. Hex becomes very, very heavy-handed when you're writing DBC files. It makes things a little bit easier to understand in most circumstances. But we'll start with the left front sensor, and for this information, I'm only going to do channels 1 through 4, because you simply copy the process and follow all the significant information downstream. So let's get started. So we have here, we're going to have a canned message. We're going to add a message, right-click, add message. We want our message to be the left front IR temp sensor. So I'm going to double-click it, LF. You can't use spaces on names. You can use spaces on comments, but any name that you have in any DBC file will not accept any special characters. It can be upper and lowercase and underscore, and that's about it. And the reason being is because they use a lot of special characters in order to define this file. So if you start using special characters and spaces, it throws off the parsing. So we're going to left front IR underscore temp. Our ID is 1200 decimal, 4BO, and hex. I can hit here and get 4B0, and we get 1200 decimal. Those two work together. So if I took 1201.01, turns into 4B1. See how that works? All right, our frame format standard. We're not using extended IDs, but you have the option between standard or extended IDs. Our data length is 8. Our transmitted node, we don't have to define, but we could if necessary. It's usually not necessary to embed this in DBC stuff unless you're working higher up the chain. If you're getting into very basics, I'm not going to throw you down that wormhole. Comments, you can write anything in the comments. It's just a comment section, but you can type this is the front IR sensor. What I'll typically do in this is any of the comments I'll try to put if it is a specific sensor, the sensor ID number, model number, and things like that. That helps me keep up with things. So if there's ever a problem with the specific sensor, and the sensor actually needs to be replaced because it's bad, I now know where to look. We'll hit OK. You can have spaces and also new line characters on this. So yep. All right, so now we need signals in selected message. So we don't have any signals in this message yet. We're gonna add a new signal to message, and this was gonna be let's do channel 1 as they stated is. Let's type it in, channel. We'll type left front underscore ch underscore 1. So there we are. Hit enter. Is it unsigned? We need to check. It is unsigned. Is the byte order Intel? Intel and Motorola, this gets kind of confusing. if you're working within 1 byte, which if you see this gray area up here, that is 1 whole byte. Also, arrays start at 0, not 1 when you work in this stuff. So it's easy to understand that you start counting at 0. So 0 is your first. It is your first iterable, as they would call it. It is your first item. So 0, 1, 2, 3, 4, 5, 6, 7. Bit positions go from right to left. Byte positions go from left to right. I know that gets confusing, but if you were to look at this all on one line, the byte number 0 would be the leftmost byte, and byte number 7 would be the rightmost byte. But I'm going to type in a length of 16 to explain Motorola and Intel, or Big Indian and Little Indian format. So if you see here that we have, and unfortunately, it doesn't matter how I can try to make this graph bigger, it does not work. But you can see there's a line starting, and you got an arrow running all the way across, and it goes from bit 0 of byte 0, scrolls all the way left, and then it would go back all the way to the right, so to speak, and go all the way to the left ending bit. That is Intel or Little Indian format. So your least significant bit starts in the byte that is on the left side. But I'm going to change this to Motorola. And you have to click something. So the length I need to change the bit position to show you, because the bit position is now starting in a different location. But now that we have it in Motorola, our starting bit position is 8. It's offset of 8. So you go 1, 2, 3, 4, 5, 6, 7, 8, because we're offsetting. Our starting bit position is 8. That's your least significant bit, and the length is 16. So it goes all the way to the left, and it jumps to the byte to the left and goes all the way to the left. If I type in and go back to Intel, you can see that it switches position. Our starting bit position does not change. Do we go move to the byte to the left or the byte to the right does change. That is something you have to pay attention to. Thankfully, they have this graph to help explain it a little bit better, because some software doesn't offer it as natively as this one. So we're looking at Motorola. It's all Big Indian and Motorola, so we can keep it at Motorola. 0.1 degrees Celsius per bit, so a factor of 0.1. 0.1. We have no offset. Oh, yeah, we do. I apologize. Negative 100 degrees offset. So negative 100. We can type in minimum and maximum. It's not necessary. Our unit, you can type in things here, any special characters and stuff like that. But for Celsius, I typically use C. And that is channel. Well, we gotta address the length here and the location. So it is okay. So it is 16. It's 16 bits or 2 bytes wide. Our most significant bit starts on the right side, so it's Motorola format. So we'll go back and type in 8 and 16. 8, 1, 6, and it is Motorola. All right, so we have one done. Add a new signal to the message. Left front, channel 2. We're going to keep everything pretty much the same. The length is 16. It's going to be 24. Factor 0.1. Negative 100. 0, 0, C. Add new signal to message. Left front, channel 3. 32 plus 8, 40. 16. 0.1, negative 100, C. And finally, left front channel 4. Left front channel 4. Go 56, 16, 0.1, negative 100, C. All right, so we'll go through and double check. We have our least significant bit followed to the most significant bit, or least significant byte to most significant byte, however you want to look at it. ID 1200, ID 1200. You can see that it highlights it has a bold area around it now. So if I go through and start clicking on them, it will show them as necessary. All right, so our left front's done. Let's move to our right fronts, 1204. So add a message. As you can see that our graph is cleared here. We'll type right front, IR, temp, 1204. It is standard. It is 8-bit, or it's 8 bytes in length. The DLC is the data length. This is the right front. Boom. Add a new signal to message. We can go through and add them prematurely if necessary. We can go right front, H1, front, 2, right front, CH3, right front, CH. Unsigned, all of them are Motorola, so we can, you end up triple clicking. They're all signals. They're all length 16, which is probably not going to let me do that because we're in the wrong bit position. 16, 24, 6, 46, 56, 1. And so, just to give you an example too, if I lower this value 1, you can see it pulls from the most significant bit area just so it's an understanding. So if I type in 18, it just keeps going up. All the factors are 0.1. Offset -100. C. 0.1. Tab -100. Tab. C. 0.1. -100. C. Shift tab. 0.1. -100. All right, cool. I'm just going to save this. We'll save it as, I'll go it on the desktop for now. Type in Izzy IR temp front. Okay. So that our signals are all done. If you want to look at all the signals, you can look at them all here if necessary. It shows all of them based on the various factors that they have, what message they're attached to. If you have signals values, these are typically enumerators. You could add these here. Any comments you wanted to add, you can also add comments in this section as well. Node list, so since we don't have any nodes, and I'm not going to get into it in this video. Nothing in communication matrix doesn't have anything as well. Our left front IR temp sensors are done. Our right front IR temp sensor is done if we're looking only at 4 channels. And we'll hit save just to show you that we pulled in. New on demo, connections, communication, import DBC file. Let's go to my desktop here. Izzy IR temp. And there you have them. So, okay, there they are. Thanks for viewing.